Hello Build Team Crash Course. Today I'm going to be sharing with you some of my knowledge about steering on a first robot. So we're going to assume a few conditions for the purpose of this video. And the first condition is that we're going to be using the frame provided by First, that is the aluminum frame. The second is that we're going to be using the standard white wheels. Third, we're going to be using the gearbox and sim setup that is standard for most first robots. And so with these three things, what we're going to be changing is where the driving wheels are and how we set up the belts between them to produce a different drivetrain. So in the model I'm going to use here, these represent the wheels. There are 3 on each side of your robot, and the square is the boundary of the robot. So the first model I'm going to talk about is called the tank drive, and is the most common one that you'll see. In the tank drive, there are from 2 to 6 motors. You can have anywhere between 1 and 3 motors attached to the gearboxes here. And these blue boxes represent the motors as attached to the gearbox. And they are only attached to one wheel on each side. So this center wheel is the only one given actual power. But on the shaft here, we have some belts. You can do this different ways if you wanted to have a wheel that's just an idle wheel. So you could take away, for example, this belt here and have this wheel a driving wheel, and this wheel also spun by the motors through this belt here. But this wheel here would just kind of go where the rest of it goes. It's there for support. But in this example, all the wheels are attached to belts. So this design is used very readily for a few reasons. The first reason is that it's a very sturdy design, and these wheels here have some reasonable traction against a surface used in First, which is generally a kind of carpet. It can withstand some bumping around. If a robot were to drive into it, the robot wouldn't go flying. It has some defensive power. This also means that it's able to push larger weights around, whether that's other robots or the playing pieces in that specific game. And you can use different numbers of motors to give it different amounts of power, depending on what you have to do in that game. So this design is widely used. I hope this video gave you some general information about building a drivetrain that works well in most circumstances. For a variety, to learn about different types of wheels and drivetrains, I'm going to send you to the next video in this series. The tank drive uses a steering system called skid steering. So essentially, we've got 2 motors, and they have belts attaching the 3 wheels together. So you can kind of think of it as 2 treads instead of 3 separate wheels. And this is a kind of steering that they'd use on tanks. So tanks also use skid steering, which kind of plays into the part that it's a stable drivetrain, if you want to think about it that way. So it can go forwards, backwards, to the left, turning, and to the right, turning. So basically, you just change the direction that the motors are turning. So to go forwards, you turn both the motors in the same direction forwards. To go backwards, same direction, just opposite of whatever your forwards is. And then for turning to the left, you would turn one motor forward and the other motor backward. And the same with the right. You just switch which motor is going which direction. So the steering is pretty simple for this, which means the coding is pretty simple for this, which also means that the handling for this is relatively easy. So this makes it an all-around drivetrain for teams to use, especially when you have a difficult subsystem to build. You don't want to be spending a lot of time on building this wacky, complicated drivetrain and then have no subsystems to put on it to show off what you've done. So this is the one that you'll see most commonly in first, and these wheels sell out really quickly, just a word of advice. So a few things about this drivetrain that I want to share with you, because this is most likely what you're going to be using. First of all, though it is really durable and sturdy, you have to remember that this is a fairly heavy drivetrain. You can put anywhere between 1 and 3 motors attached to your gearbox. So the motors will be the second heaviest thing put on your drivetrain. This here is a mini sim. So this is 2/3 the size of a sim motor, which would be about this big. And I know that you guys can't feel it, but this is a relatively heavy motor. And having 6 of these guys, 6 sims, not mini sims, 6 sims on your robot is going to be a large bulk of the whole mass. So when you're thinking about how many you want to put on, really look at how much power you need your drivetrain to actually have before deciding, I want all the motors. I hope this video gave you some general information about building a drivetrain that works well in most circumstances. To learn about different types of wheels and drivetrains, I'm going to send you to the next video in this series.